How's it going, guys? Today we're going to be going over integration with partial fractions. This is part 1 of the series where we go over the basics of partial fractions, and the next video we'll go over the integrating part of it. Let's begin. Before we begin, let's define partial fractions. Partial fractions is a method to rewrite a single rational expression as a sum of simpler fractions. To generalize this, we have p of x over q of x. The degree of p of x must be less than the degree of q of x. So the degree means the highest exponent. So for example, in x squared minus 2x, the degree here is the 2. And so we factor the q of x, and we can express it as a over factor 1 plus b over factor 2, and so on and so forth. Each term has a simpler denominator, which makes it easier to work with, especially for integration, which we will go over in the second part. The first question here asks, what is the first step in performing partial fraction expansion? And so the first step is factoring the denominator q of x into simpler forms, which will help us integrate. And so the answer is 2. Now it asks, which of the following shows the correct factors of the denominator in the fraction shown below? So the denominator is the 2x squared minus 5x minus 3. So we need to factor this, and we will factor using the rainbow method. And so we connect these two outer numbers and we multiply them to give us negative 6, and the middle number here is negative 5. So now we need to find two numbers that multiply to negative 6 and they add up to negative 5. The two numbers here are negative 6 and 1, because negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5. So let's drop the 2x squared to give us 2x, and then we'll add the plus 1 here, and we'll have an x on the other side, on the other bracket, and we will write a minus 6, but because there's a 2 on the other side here, this becomes a minus 3. So we got the minus 6 and we divided it by the 2 on the other side to give us x minus 3. And so we can actually FOIL this out to double check our work. So 2x times x, 2x squared, 2x times negative 3 gives us negative 6x. 1 times x is x, and 1 times negative 3 is negative 3. And so we add like terms to get 2x squared minus 5x minus 3. So we know that we factored it correctly. And so that is our answer, which is 1. The final question here is this. Which of the following is equal to the fraction shown below? The first step calls us to factor the denominator, and the question actually gives us the factor denominator, so we get to skip step 1. Now we set it equal to a over factor 1, which is x minus 6, plus b over factor 2, which is x plus 2. Now we have to solve for a and b, but before we do that, let's get rid of these denominators here. And we can do it by multiplying both sides by x minus 6 times x plus 2. And so these two cancel out completely, giving us x plus 34. And on the left side, the first term becomes a of x plus 2, and the second term is b of x minus 6. To solve for a and b here, we can plug in x for specific values. So we can start with x equals negative 2. And I will explain later to you why I said x equals negative 2. So if we have x equals negative 2, we get negative 2 plus 34. That gives us 32. Then we have a of negative 2 plus 2, which is a of 0. And this actually cancels out to give us 0. And then b of negative 2 minus 6 which is negative 8. The reason I said x equals negative 2 is because the x plus 2 cancels out to give us 0, and then we are just left with b, and we can solve for b. And dividing both sides by negative 8, we get b equals negative 4. Now we need to solve for a, and so we need an x value that can cancel out b from the equation. And for that to occur, we need x to be equal to 6. And so plugging in our x values, we get 40 on the left side equal to a of 8 plus b times 6 minus 6, 0. So it cancels out. And so isolating a on one side, we get a equals 5. Now that we have the a and b value, we can go ahead and plug that in, and we get 5 over x minus 6 plus negative 4 over x plus 2. And that is our answer. And let's match it up with one of the options. And it is option 2. Thanks for watching. I hope you enjoyed, and stick around for partial fractions part 2. Please consider liking and subscribing, and I'll see you in the next one.